So in today's class, we'll be covering the portions which are given in the syllabus, and that is weathering and erosion. Okay. So we'll start with this weathering part. Okay, weathering part. Simply, what is weathering? Weathering is the breakdown and alteration of minerals near the Earth's surface to the products that are more in equilibrium with newly imposed physico-chemical conditions. Right. This is one definition. Many people have tried to give their own definitions to weathering. Right. Many definitions will be there. Many concepts might be there. But a simple and most comprehensive concept. Okay. The simplest and the most comprehensive concept is that there is just the breakdown. Okay, breakdown of material due to natural agencies. Okay, the breakdown of rock material, breakdown of rocks, breakdown of earth materials due to natural agencies. Now these natural agencies might be anything, right? These natural agencies might be anything, right? That is, they might be a river. Okay, it might be a glacier, it might be wind, right? It might be groundwater. Okay, it might be ocean, right? Any of this, or it might be climate. Okay, it might be climate. Climate is also a geological agency or the natural agency which carries out the weathering, right? So all these agents, okay, all these agents, these are collectively called as weathering agents. Okay, these are collectively called as weathering agents, and these weathering agents go for the weathering of the rocks. Okay, go for the weathering of the rocks, and these weathering of the rocks will simply break down the material. Okay, simply break down the material. Say suppose this is a rock A. Okay, this is a rock A. Now it has been acted upon by a river once. Okay, for some years it has been acted upon by the river, then acted upon by the wind, and then that river got converted into glacier, and it was acted upon by the glacier, and so on. Right? Will the rock remain same as that of its original rock? It's obviously not. Right? Obviously not, because its composition will change. Right? Its composition will change. It was used to be rock A. Now it might be rock A minus one, A minus two. 1, 2 represents the minerals and the composition. Right? So if it used to be a basalt or granite, say suppose. Okay, if this rock was the granite, okay, will it remain granite after several cycles of erosion or several cycles of weathering? Not at all, right? Not at all. Why? Because whatever feldspar is present, okay, whatever the feldspar is present, because feldspar is most susceptible to weathering. Okay, feldspar is more susceptible to weathering. So this feldspar will removed off, right? Feldspar will removed off, or if chemical weathering is done, feldspar will be converted to clay, right? This feldspar will be converted to clay, and the original rock composition, okay, the original rock composition which used to be granite or granitic composition has now been changed to something else. Right? It has been changed to something else. So the original rock loses its identity, and once its identity has been lost, right? The identity has been lost. It is a new rock. Okay, it is a new rock, or it is a weathered material, or it is a weathered rock, right? So this is the whole concept of this weathering. Okay, this is the whole concept of this weathering. Many people have tried to explain this concept, but there are some basic structures which we have to look for. Okay, understood this? So this is the basic concept behind weathering. Okay. Now, there are two types of changes. Okay, there are two types of changes in the weathering: physical, okay, physical or mechanical changes. Okay, physical or mechanical changes in which uh, you can see exactly the process happening or the results in front of you, right? In which the rocks disintegrated through temperature changes, frost action, biological activities, wind action, etc. Okay, so these are the physical changes. That means the physical tear and wear of a rock, right? Physical tear and wear of the rock. And chemical changes, wherein rocks are decomposed through static water, oxygen, carbon dioxide, and biological activities. Right. So these activities are very much slow. Okay, these activities are very much slow, and this cannot be witnessed very often. Right. This cannot be witnessed very often. Right. So breakdown of the rock occurs at the place of the rock. Okay, that is called in situ breakdown. Right. The in situ breakdown. There is no large scale transport of weathered material, right? Weathering and erosion, right? Weathering and erosion, they are essentially the same concept, right? Weathering and erosion is essentially the same concept, but there is a difference or there is a fundamental difference between these two. Okay, fundamental difference between these two, and this fundamental difference is this: transport. Okay, the fundamental difference is this: transport. The weathered material or the weathering is a process which is in situ, right? Weathering process is in situ process. That means where the rock was originally present. Okay, where the rock was originally present, the broken down material will found at the very place, right? Whereas in case of erosion, you won't find the in situ breakdown of rocks, right? The in situ breakdown of rock is not witnessed, but there is a large scale transportation. Okay, there is a large scale transportation. That means the rock was broken at somewhere else, and the material has been deposited at somewhere else, right? So this kind of transportation, okay, this kind of transportation is involved in erosion. Okay, transport this weathering involves it does not involve any kind of transportation, or there is no large scale transportation. It is not like there is no transportation at all. Okay, no transportation at all. This is actually impossible, that there should not be any kind of transportation. There will be transportation, but that will be negligible. Okay, it will be transported by some, say, 5 meters, 10 meters, right, like that. But it won't be like that hundreds of kilometers it has transported from its origin, right? It is not like that. Okay, so weathering may be defined so as to include all the aspects of mechanism of breakdown of the rocks is follows. This is the highly technical definition or highly advanced definition, I can say. Okay, weathering refers to the breakdown or disintegration and decomposition of rocks in situ through mechanical and chemical changes in the rocks and their minerals affected by water, temperature, wind, different atmospheric gases, and organisms, provided that there is no large scale transport of weathered product by denudational processes except mass movement of rock waste down the slope under the impact of gravity, right? This is the most comprehensive definition of weathering. Okay, the most comprehensive definition of weathering. You can remember this if you want to, or if you don't want to. Okay, got this? Weathering. So this is the concept of weathering. Now, if there is a weathering, there must be some controlling factors. There must be some controlling factors. There are some of the controlling factors of weathering. Okay, in the geomorphic concepts. Okay, in concept of geomorphology in the yesterday's class, you might have you might have heard about this concept. Okay, you might have heard about this concept that geomorphic climate is a dominant factor in the formation of geomorphic features, and it is shown in the features, right? This is one concept. Okay. So the composition and the structure, the controlling factors. The first controlling factor is the composition and structure of the rocks. Okay, the composition and the structure of rocks. What is the composition of the rock is a very important criteria. Okay, what is the composition of the rock is a very important criteria. Why is it so? Because on the basis of its composition, the weathering pattern of the rock is dependent. Okay, weathering pattern is dependent on the composition, right? So weathering involves the disintegration and decomposition of the rocks, and hence mineral composition, joint patterns, layering system, faulting, folding largely affect the nature and intensity of weathering, right? More the rock is weathered, or more the rock is faulted, fractured, or jointed, right, or layered, it will be more susceptible to weathering because it is already weakened, right? The rock is already weak. If it is highly folded rock, if it is highly faulted rock, if it is highly jointed rock or highly fractured rock, these the natural agencies will act on these rocks more readily, right? Natural agencies will act more readily because they do not have to work hard on that rock. Okay, they don't have to work hard on that rocks, but this rock themselves are providing the sites or providing the area for weathering to the natural agencies, right? So this mineral composition, if the mineral composition is there which is not that competent, okay, incompetent minerals are there. Okay, just a minute. Okay. So as there are more incompatible minerals, okay, more incompatible minerals, or the minerals which are not that resistant to weathering, okay, that are resistant to weathering, they will be removed off first. Okay, you might be knowing about this Bowen reaction series. Okay, you might be knowing about the Bowen reaction series, but there is one more series which is called as Goldich series, right? The Goldich series. What is this Goldich series? Goldich series is nothing but the opposite of Bowen reaction series, because the Bowen reaction in the Bowen reaction series, olivine forms first, right? The olivine forms first. This is even the first mineral to be removed from the system. Okay, to be removed from the system, right? Quartz forms at the last at the final stage. Okay, quartz forms at the final stage. It is the highly compatible mineral or highly tolerant mineral to weathering, and it does not get weathered. Okay, it does not get weathered. It remains in the system for longer amount of time, larger amount of time. Okay, so you might be thinking about this. If you have watched this Sacred Games, Sacred Games पाहिलं सगळ्यांनी? Sacred Games नावाची एक सिरीज होती काय 2-3 वर्ष आधी. पाहिली आहे का? अरे येस और नो, झोपले का रे?
No, sir.
नो, इतकी फेमस सिरीज नाही पाहिली? In that in that Saccard games, okay, in that Saccard games, there was one dialogue that सब मर जाएंगे सिर्फ त्रिपाठी बचेगा, right? सब मर जाएंगे सिर्फ त्रिपाठी बचेगा. So Quartz is a Tripathi of geology, right? The Quartz is Tripathi of geology. Now what is this? Because everything dies out, right? Everything dies out, everything gets uh, weathered and eroded, okay, but quartz remains. Okay, quartz remains. Quartz does not get eroded very easily. It needs highly chemical environment. Okay, so if carbonate rocks are there, okay, if carbonate rocks are there, the calcium carbonate, magnesium carbonate, or this limestone or dolostone, whatever, okay, they are easily affected by chemical weathering. Okay, well jointed rocks are more subjected to mechanical disintegration, right? Rocks having vertical set are easily loosened and broken down due to temperature changes, okay, and so on. So these kind of compositions of the rock, okay, this kind of composition and the structure of the rock, it will go for more weathering. Okay, if there are more structures developed, more incompatible minerals are there, they will be disintegrated very easily. But if there is more quartz, okay, if there is more and more quartz, or more and more compatible minerals, the rock is crystalline properly, right? Rock is properly crystalline, rock is not that broken. What will happen? It will be more, it will sustain the forces, or it will sustain the weathering agents for more amount of time. Okay, then the nature of ground slope. This is again an important or dominant feature. Okay, the ground slope controls the mechanical disintegration of rocks and mass movement of weathered product with, down the slope. The rocks in the regions of steep hill slope are easily disintegrated due to mechanical weathering, and the weathering materials are instantaneously moved down the hill slope in the form of rock fall, debris fall, and slide, talus creep, etc. Right? So on the slope, the rocks are already weakened. Okay, down the slope, the rocks are already weakened. You might have seen this. If you are going to any of the hill terrain, okay, go to any hilly terrain, okay, on the slopes, if the rocks are there like this, okay, if the rocks are there, these rocks are either bolted, okay, these rocks are either bolted, the longer rebars, they are inserted in the rocks, right? The longer rebars are inserted in the rocks, or there is one net which is constructed, or which is tied up along these rocks, so that the rocks should not fall down, right? Have you observed this? Observe this. Go in any of the hilly terrain which is not that stable. Okay, for instance, you can go to this uh, Muktagiri, Amravati district. Okay, go to Muktagiri. Jain temples are there. Okay, very beautiful place. Okay, it is a very beautiful place. Go to Muktagiri, and once you start climbing to the Muktagiri temples, okay, you will find there are the rocks, these rocks which have been bolted, okay, which have been bolted, and you can see this, the large bolts are there. Okay, so that these rocks should not fall down, right? So these rocks on the slopes, okay, rocks on the slopes, they are already very much unstable. Okay, they are already very much unstable. Now this instability or this instability of the rock, okay, this instability of the rock will lead to, okay, this instability of the rock will lead to the formation of this mass movement, okay, for the mass movement, right? And this mass movement will come down on the mass uh, in the form of steep hill, in the form of this chemical weathering, okay, in the form of this rock fall, then debris fall, then slide, talus creep, etc. Okay, so they will be disintegrated faster. Okay, they will be disintegrated faster, and they will go for more and more weathering. Then comes the climatic variations, again a dominant factor. Okay, the climatic factors. Okay. See, I have given you this concept, or I have told you that there is a concept Okay, there is a concept in geomorphology. Each climatic type produces definite conditions of particular type of weathering. Right. So each climatic condition or each climatic type will have their own climate or geographic own geomorphic features or own geomorphic signatured features. Right. So this will give you the insight of the climates. Right. Each and every type of structure or each and every type of geomorphic feature cannot be produced in each and every type of climatic region, right? Just like the karst topography. Okay, karst topography cannot be formed in the desertic environments, right? Karst topography cannot be formed in the desertic environment or desertic climates, right? Or moraines cannot be formed. Okay, lateral moraine, end moraine, these cannot be formed in river, right? In the humid climates. Okay, for moraines to form or for silk to form or tarn to form, you need a glacier, you need permafrost conditions, right? You need permafrost conditions. Or for the alluvial cone, alluvial fan, you need humid climatic conditions, you need the river. It cannot be formed in the arid climatic conditions, it cannot be formed in the oceanic climatic conditions, right? So each geomorphic feature, okay, each geomorphic feature is dominated by their climatic conditions, right? It is dominated by their climatic conditions, and these climatic conditions, they follow or they form a particular type of weathering as well, right? For example, chemical weathering is more dominant in humid tropical areas because of more available water and high temperature, right? Because of abundance of moisture and high temperature, leaching process and solution of rocks are more effective in humid environment. So in such humid environments, okay, in such humid environments, these kind of chemical weathering is more susceptible. Mechanical weathering is less effective, right? Mechanical weathering is less effective. Why? Because leaching process is going on. Okay, whatever the mechanical processes are, they need more open environment, more hot environment, right? Mechanical disintegration of the rocks is more dominant in the tropical and semi-arid regions. Okay, rocks are weakened due to alternate expansion on heating during daytime and contraction on relative cooling during nights because of diurnal changes, right? These kind of climates are required for the mechanical weathering, right? So these are the climates. Okay, these are the climates which affect. Okay, these are the climates which affect the weathering process and the floral effects. Okay, floral effects. Floral effects means the vegetation. Whichever kind of vegetation is there. Okay, whichever kind of vegetation is there. So nature of weathering is largely determined by the presence or absence of vegetations in a particular region. Okay, so it might be pointed out that vegetation is partly factor of weathering and partly protector of rocks, right? It is partly the factor of weathering because its roots try to break down the rock. Okay, its roots try to break down the rock as the roots go deep and deep. Okay, as the roots penetrate deep and deep, they try to break the rock and they make their own hold in the land. But they are partly the protector of rocks also, because they protect the rock from the mechanical weathering, the other factors of mechanical weathering, right? Through their network of roots, thus protect them from weathering and erosion. But at the same time, penetration of roots weakens the rock by breaking them into several blocks. So it is one and the same thing. Okay, it is breaking the rock as well as it is protecting the rock. Okay. So there are three types of weathering. There are three types of weatherings. Okay. The first one is physical, then chemical, then biological. Okay. Physical, chemical, and biological. So what is this physical weathering? Due to moisture and water, then frost, then insolation, wind. Chemical weathering agents: oxygen, carbon dioxide, hydrogen, and biological: vegetation and animals. Right. Let us see them one by one. What are those, and how do they go for weathering, or how do they go for the this rock disintegration process? Okay. Okay. The first one, the first one is the physical or mechanical weathering. Okay, the physical or mechanical weathering. Now, what is this physical or mechanical weathering? Physical or mechanical weathering is due to the physical action, right? Physical action. That means it will go for breaking of rock, right? It will go for breaking of rock by penetration of something, right? Penetration of something, just like uh, somebody has hammered the rock, right? Somebody has hammered the rock, and due to this hammering, the rock has been broken into pieces, right? So basically breaking down of rock into the pieces due to any kind of natural agency, okay, without changing its composition, right? Without changing its composition, that will be called as a physical weathering. Okay, that will be called as physical weathering. So in the physical weathering, the original composition of the rock does not change, but the size of rock, the dimensions of the rock, and the overall nature of the rock, okay, the overall existence of the rock, that changes. Okay, the overall the existence of the rock changes, but the chemical composition, okay, mineral composition, that does not change. Okay, chemical and mineral composition does not change. Okay, it will remain as it was. Okay, it will remain as it was. But the but early if the rock was like a huge rock, okay, like 1 kilometer by 1 kilometer dimension of the rock, okay, 1 kilometer square dimension. So next, after the physical weathering, that rock might have attained the dimensions of say 500 meters. Okay. This is nothing but your physical weathering. So physical or mechanical weathering leads to fragmentation and breakdown of rocks into big blocks or boulders. Cobbles and pebbles, sand and silt, and feldspar and mica minerals are chemically decomposed. Okay, these are chemically decomposed, right? So physical weathering may be defined as the disintegration of rock due to the temperature variations, frost action, wind action, unloading, confining superincumbent pressure, etc. Right. So there are various types of this weathering. Okay. First one is the block disintegration due to temperature changes. Okay. Block disintegration due to the temperature changes. Now, temperature changes due to whatever the block disintegration is. Say this is a block or this is a rock. This is a rock, any rock. It has been acted upon by sunlight. Okay, it has been acted upon by sunlight. Now there is there is a tendency of any material. Okay, there is a tendency of any material to acquire or to absorb the heat, right? To absorb the heat, just like you might be knowing about the sea breeze and land breeze. Okay, the sea breeze and land breezes. Why the sea breeze and land breezes occur? Due to the temperature variations themselves, right? The earth materials, that is the rock materials, okay, rock materials gets warmer very easily or very quickly, right? They get they acquire temperature very easily, and they lose temperature very easily, right? So what happens is, when a rock, okay, when any rock gets more and more sunlight, okay, gets more and more sunlight, okay, it virtually expands. Okay, it expands, just like you give the material, give temperature to some materials, it will expand, right? It will expand. But since this is a rock, okay, since this is a rock, it cannot hold the heat. Okay, it cannot hold the heat, it will have to lose the heat, right? Once the temperature has gone down, okay, the atmospheric temperature has gone down, it will start to lose heat. Okay, it will start to lose it. Now when any material is losing it, it is getting contracted, right? It is getting contracted or compressed, right? This process, okay, this process will go for will be happening for longer time. Okay, this process will go for longer time, say for um, 15 years, 20 years. Okay, this much amount of time it will take to go for this process, and continuously this process is going on. Okay, the continuously this process is going on. What will occur then? Once a time will come when this rock will be broken due to this repeated temperature changes. Okay, this repetitive temperature changes, and this will lead to formation of smaller blocks. Okay, this will be lead to the formation of smaller blocks, and these smaller blocks will be broken down. Okay, the entire rock will be broken down. It will be shattered into the pieces. Okay, it will be shattered into the pieces, and then it will be completely disintegrated. Okay, so the products of weathering, these products of weathering, okay, in hot deserts are different from that of more humid, and they are coarser and deficient in clay and organic matter. So this is about the composition. Okay, this is about the composition, but yes, the process remains the same. Okay, process remains the same, right? Just remember this. The example of glass. Okay, the example of glass. I have given you this example even earlier. Okay, get the glass and heat it till it becomes red hot. Okay, till it becomes red hot, and insert it into water. Okay, insert it into water. What will happen? It will be shattered into pieces. Okay, it will be shattered into pieces. This is the same thing we are observing with respect to the rocks here. Right? Take the rock, heat it, put it into water, or put it into cold water. It will be completely shattered into pieces, and it will be broken down. Okay, it will be broken down, and it will be in the block. It will be converted to the blocks. That's it. Right. So this process will be called as block disintegration due to temperature. Okay. Next, the granular disintegration due to temperature changes. If coarser grain rocks are there, right, the coarse grain rocks are more affected by shattering process in those hot deserts which are characterized by a high range of daily temperature. If the rocks are coarse grain and different colors, they absorb insolation differently, right? You might be knowing this, you might be aware of this, that different colors absorb heat differently. Insolation means color, this heat. Okay, insolation basically means the heat, right? So different colors absorb the heat differently. Okay, different color absorb the heat differently, and these rocks, okay, these rocks, many color, if many colors are there, okay, many colors are there, that means many colors means many kind of rocks, many kind of minerals. Okay, many kind of minerals, not one single mineral is there, but many kind of minerals are there, right? So the different part of the same rock must receive and absorb different amount of insolation. Consequently, the different parts of the rock are affected by differential expansion and contraction, right? So if the absorption is different, right, absorption is different, these different absorption will have different expansion and contraction, obvious, right? It is very much obvious, right? So this contraction which causes stresses within the rocks, due to which they are disintegrated into smaller particles. Okay. Now here there is no equal, or there is no equal kind of breaking is there. Right. There is no equal kind of breaking is there. There will be differential breaking. Okay. Differential breaking, and simply it will be converted to grains. Okay. It will be converted to the grains. So such type of shattering of rocks is called as granular disintegration. Okay, this is granular disintegration, and this granular disintegration is active in hot desert areas. Okay, wherever the hot desert areas are, just like Rajasthan, or just like our Sahara Desert or Kalahari Desert. In this kind of desertic areas, this granular disintegration is very common. Okay. Then shattering due to rain, shower, and heat. The outer shells of the rock are shattered due to the sudden light showers in hot climatic regions, mainly in hot desert areas. It is like spreading water on the hot sauce, hot pan, right? तव्यावर पाणी मारण्यासारखं आहे ते. ठीक आहे. Outer shell is very much hot. Okay, outer shell is hot, and suddenly it has been acted upon by the rain. Okay, suddenly it is acted upon by the rain. What will happen? It will be suddenly cooled and broken down. Okay, suddenly will it will suddenly be cooled and broken down. Okay. So that is nothing but this process. Okay. Then block disintegration due to frost. Okay, block disintegration due to the frost. Now this is one more interesting thing. Frost action. Okay, disintegration of rocks into large size blocks due to freeze and thaw of water is a common occurrence in temperate and cold climatic regions. Okay, what happens is, say suppose this is your rock. Okay, this is one rock. It has developed some cracks. Okay, it has developed some cracks. Now these cracks are filled by water. Okay, these cracks are immediately filled by water, and this rock is belonging to, okay, the rock is belonging to the these colder climatic areas. Okay, colder climatic areas. What will happen? These this water which is collected here. Okay, the water which has been collected here, it will be frozen. Okay, the water will be frozen, right? Now the tendency of water is, when it freezes, okay, when it freezes, it expands its volume. Okay, it expands the volume, right? This is the ambiguous anomalous behavior of water. Okay, this is the anomalous behavior of water, right? Water is the only liquid which expands its volume on cooling, right? So when the rock is having cracks, okay, when the rock is having cracks, and in which the water has been deposited. Okay, water has been deposited, and when the when due to this these colder climatic conditions, the water has been frozen. Okay, water has been frozen. So this frozen water will expand. Okay, once it is expanding, okay, once it is expanding, it will be generating some pressure. Okay, it will be generating pressure, and this pressure, okay, this pressure is acting upon by at the walls of the rock. Okay, walls of the rock. So the cracks are getting widened. Okay, cracks are getting widened. Now when the colder climate or the colder climatic conditions are over, or the summer is there, the water the ice will melt, right? The ice will melt, and it will be converted to water once again. The widened cracks will try to shrink. Okay, the widened cracks try to shrink again. Colder climates came. Okay, again again the rock cracks will be widened again, shrink again, widen again, shrink. So this widening and shrinking of the cracks, okay, this widening and shrinking of the cracks, they will lead, okay, they will lead to the breaking of the rock, right? So first it was widened like this, then shrunk, and next time it has widened once more, bit more, again it has widened bit more, again it has widened bit more, and the rock has been broken. Okay, the rock has been broken. So this repetitive freeze and thaw conditions, okay, this repetitive freeze and thaw conditions has led to the breaking of the rock, or the mechanical breaking of the rock, and this will create the mechanical or physical weathering, right? So frost action weakens the rocks into two ways: due to freeze and thaw of water between the particles of the rock, due to freeze and thaw of water in the crevices and pore spaces, which I have given you. Okay, the more compact and highly consolidated rock, like granites, are least affected by freeze thaw actions, while less compact and loosely consolidated rocks are more affected by the frost action. This is a very obvious thing, and this is known to everyone. Okay. Next is exfoliation. Okay. Next is the exfoliation. Now, this exfoliation is also known as onion type of weathering. Okay. Onion weathering. It refers to the peeling off of concentric shells of rocks due to combined actions of heat and wind in hot, arid, and semi-arid regions in monsoon lands. Right. Exfoliation is more common over crystalline rocks. Right. What happens actually is, if say suppose this is a rock, okay, this is a rock, right? Concentric shells are there, right? These kind of concentric shells, they are removed off. Okay, they are removed off, right? So hence one shell is peeled off, right? One shell is peeled off, and hence this kind of weathering is called as onion weathering. Okay, this kind of weathering is also called as onion weathering. This is the combined effect of temperature and wind. Okay, this is the combined effect of temperature and wind, right? Now here, the outer shell of rock becomes loose due to alternate expansion and contraction due to high temperatures. Okay, due to high temperatures during day and during daytimes, and comparatively low temperatures during the night. Okay, these loosened shells are removed by the stronger winds. If the strong winds are there, the material which has been loosened up, that is removed off. Obviously, this process is not easier process, or this process is not a instantaneous process just which you can observe happening. Okay, you cannot observe this process happening, but yes, this process is very much common process, right? So differential heating of outer and lower shells of a rock mass causes flaking. Means the formation of different shells. These are the different shells. Okay. Disintegration and exfoliation due to unloading. Okay. The rocks which are buried under thick covers of overlying rocks are disintegrated when they are exposed to the surface due to the removal of superincumbent load and consequent release of confining pressure. This is very much analogous to the retrograde metamorphism. Okay, retrograde metamorphism. What happens actually in the retrograde metamorphism is pressure and temperature are getting reduced, right? Pressure and temperature are getting reduced. That means uh, if any rock is under high pressure, it has now been coming under low pressure. Okay, so this transition from high pressure to low pressure reduces the actual pressure which has been exerted on that rock, right? So it will bring about some changes in the rock, right? It will bring about some changes in the rock. The consequent release of confining pressure. Okay, if the pressure has been released, okay, if the pressure has been released, it will the rock will try to regain its original dimensions, right? The rock will try to regain its original dimensions, and while it is trying to try to come into their original dimensions, okay, it will be broken. Okay, it will be broken. So this process is known as unloading. Okay, it will be called as unloading, right? So these granites, okay, granite, sandstone, massive arkose, conglomerates, limestone, they are more affected to the unloading. Okay. This sheeting process refers to the development of cracks and fractures parallel to the ground surface caused by removal of superincumbent force or superincumbent load, resulting into reduction of confining pressure. Such parallel cracks and fractures are developed in massive rocks such as granites and other igneous intrusive quartzites and thickly bedded sandstones because of expansion of rocks consequent upon unloading superincumbent loads. Okay, if parallel cracks are developed, okay, if parallel cracks and fractures are developed, it will be called as sheeting, right? Got this? So this is all about physical weathering. Okay, this is all about the physical weathering. Understood? You have any questions in physical weathering? Anything to ask in physical weathering, or shall I move forward to chemical weathering? Okay, let us move forward to the chemical weathering process. Now, chemical weathering means the chemical action of the. What is wrong with my system? Okay, the chemical weathering of the rock, right? The chemical reaction of the rock, what rock actually is, this is nothing but a chemical component, right? It is a chemical component. Magma is a chemical liquid, chemical fluid, and that chemical fluid that has been solidified to form a mineral, ultimately a rock, right? So rock is nothing but a product of chemical processes. Okay, rock is nothing but a product of the chemical processes, right? So it is reactive. The rock is reactive, right? Something like that. It has quartz, right? Quartz is least reactive, right? Quartz is least reactive. It is not non-reactive, right? Quartz is not non-reactive. Quartz is least reactive, right? So if such the chemicals are there, okay, if such processes are there, okay. Now, in the previous section, that is in the physical weathering, what we have seen is that there is no chemical composition, or there is no change in composition of a rock, right? There is no change in composition of the rock. But here in this case, there will be the change in composition, right? There will be change in chemical composition or mineral composition of the rock due to several aspects, several reactions. What are these reactions? Let us see. Okay, the first one is the solution. Okay, the first one is a solution. Now, solution is considered to be the first step in chemical decomposition. Okay, solution refers to the dissolution of soluble particles and minerals from the rocks with the help of water in motion. But a thin film of water around a solid particle also leads to chemical dissolution. Simply, what solution actually means is that take a bowl of water. Okay, take a bowl of water, try to insert some salt or sugar in it, and stir it. Okay, you will get a solution, right? You will get a solution. Now, two things. mm, the solid is dissolved into this liquid, right? The solid is dissolved into a liquid, into water, right? So this forms a solution. This is nothing but the process of solution in rock themselves, right? So the water try to dissolve the mineral, whichever the dissolved minerals are there. Okay, whatever the soluble minerals are there, or soluble particles of the rocks are there, soluble parts of minerals are there. These parts of minerals or rocks, they will be dissolved into the rock, into the water, and will be removed off, right? It will be removed off, leaving behind the original rock, right? Leaving behind the original rock. Now the original rock has been changed in their composition, because its major composition has been removed off, right? Its major composition has been removed off, right? So the solution of rock depends upon the nature of rocks, solubility of rocks or solids, and the ratio between volume of solution and the solids, obviously, right? So the limestones are more susceptible to solution process, which depends on temperature. Okay, which depends on temperature, carbon dioxide. Okay, carbon dioxide, then content of water, pH of the solution. Okay, when pH of the solution, when rainwater mixes with atmospheric CO2, it becomes active solvent. Okay, when rainwater mixes with the atmospheric carbon dioxide, it becomes active solution. And when it comes in contact with the carbonate rocks, such as limestones and dolomites, it dissolves the rocks through the set of chemical reactions. Right? You might have heard about this Taj Mahal. Right? Taj Mahal. Taj Mahal is now pitted. Right? Taj Mahal is now pitted and yellowed. The white marble which was there, okay, the white marble which was present in Taj Mahal is now fading, is now getting yellowed. Right? Why is it so? It is due to the chemical weathering. Right? This is nothing but the example of chemical weathering. This is the classic example of chemical weathering. Is that carbon dioxide, the CO2 contained in the atmosphere of the Agra is so much or so high that rainwater has rainwater mixed with the atmospheric CO2, and it has become an active solvent. Okay, it has become the active solvent. That rain fell on the Taj Mahal. Okay, and since Taj Mahal is made up of marble, okay, it is made up of marble. Essentially, it is CaCO2, it is calcium carbonate. The more soluble part of calcium carbonate has been removed or has been dissolved into that water and started to remove it. So, giving the yellow appearance or pitted appearance to the consolidate walls, right? So this is a classic example of solution. And uh, this limestones and dolomites. Okay, limestones and dolomites, they are more susceptible. Okay, they are more susceptible to the chemical weathering due to the solution. Okay. Next is the oxidation. Okay. Next is the oxidation. The chemical processes of oxidation simply means the reaction of atmospheric oxygen to form oxides. Okay, reaction of atmospheric oxygen to form the oxides. Okay, when water is mixed with oxygen, its reaction with the minerals of the rocks forms hydroxide. Okay, we have read this redox reactions. Okay, about this redox reaction, reduction and oxidation, right? Reduction and oxidation. So OX, that is oxidation. Oxidation means uh, mm, reaction of the atmospheric oxygen to form the oxide. It will form the oxides. Okay, the rocks will get reacted, right? The rock will get reacted with the atmospheric oxygen. Okay, and it will form the oxides. Okay, if water is there, okay, if water is there, it will form hydroxide. Okay, the atmospheric oxygen after reacting with the rock produces several types of oxides, iron oxide being the most important, which weakens the rock to disintegrate. When the oxygen will react, what it will do, okay, what it will do, it will convert the minerals into oxides. Okay, it will convert the oxygen into it will convert the mineral into some of the oxide, just like this iron oxide. Okay, iron oxide, and this iron oxide will get accumulated at the top or in somewhere in the rock itself. Okay, it will disintegrate the rock. Okay, it will disintegrate the rock since it is leaching out some of the materials from the rock, right? It is leaching out some of the material from the rock, and this leaching out of some of the material of the rock, this will go for the weakening of rock, and essentially it will be broken down. Okay, the oxidation of minerals of the rocks by gaseous oxygen become possible when oxygen is dissolved in water. Obviously, if the oxygen is dissolved in water and such water is coming in the contact of rocks, okay, it will go for oxidation. Okay, for example, the best example for this is rust. Okay, rust. You might have heard this, or you might have seen this. The rusting. Okay, if you keep iron in water, okay, if you keep iron in water, it will be rusted. Okay, it will be rusted, right? So what rust basically is, rust is nothing but this: Fe2O3 dot thrice H2O. This is rust, part and parcel of iron as well as water. Okay, as well as water, but with the help of atmospheric oxygen. Okay, with the help of atmospheric oxygen, right? So the rocks are also the rocks are also rusted. Okay, the rocks are also rusted. Okay, and the rusting of rock weakens them, and ultimately the rocks are disintegrated. Okay, you might have seen this very interesting phenomenon in rocks. Okay, is that uh, Vindhyan sandstone, or not Vindhyan sandstone, any of the quartzite which is belonging to Archean age, okay, Archean age, okay, or Kadappas, okay, Kadappa's age, or prior to Kadappa, okay, or prior to Vindhyan basically. These rocks are whitish in color, or different in color, buff color, but after Vindhyan, okay, after Vindhyan, the color of sandstone is red. Okay, the color of sandstone is red, or quartzite is red. Why is it so? Why is it so? The weathering has to do something with this. Okay, because prior to Vindhyan, there was no oxygen. Okay, prior to Vindhyan, there was no oxygen. After Vindhyan, or it is in the Vindhyan, when oxygen was spread in the atmosphere. Okay, oxygen was spread into the atmosphere, and this spread of oxygen, okay, the spread of oxygen in atmosphere, it acted upon with the rock and started rusting the rock, and hence the Vindhyan sandstone is essentially red in color. Okay, Vindhyan sandstone is essentially red in color. The red fort is made up of Vindhyan sandstone, right? Red fort is made up of Vindhyan sandstone, and just because it is made up of Vindhyan sandstone or red sandstone, it is called red fort, right? Okay, next process is the carbonation. Okay, next process is the carbonation process. Okay, now the carbonation is the reaction of carbonate or bicarbonate with the minerals, obviously. Okay, carbonate and bicarbonate, same process as that of the solution. Okay, same process as that of the solution. Just here, the just here the process it is with respect to the carbonates or bicarbonates, right? Wherein atmospheric carbon dioxide after mixing with water forms carbonic acid, okay, which after reacting with the carbonate rocks, say limestone, forms calcium bicarbonate, which is easily dissolved in water, so it removes the calcium carbonate and so on. Just here, the carbonate and bicarbonate specifically are involved. The process is carbonation. Okay, the process is carbonation, or else everything is similar as that of the solution. Next is hydration. Okay. Next is the hydration. Now, what is this hydration? Hydration is the process. Okay. Hydration is process is related to the addition of water to the minerals. Okay. In any mineral, if the water is added, okay, if the water is added, right, in the chemical composition of the mineral, right, in the chemical composition of the mineral, the water is added, right. In such conditions, hydration will occur. Okay, the rocks after having absorbed water undergo the process of positive change in their volume. Obviously, if you include one molecule of water in any chemical composition of a mineral, okay, its volume will increase, right? Its volume will increase. In other words, the volume of the hydrated rocks increases remarkably. So entire volume of the rock will increase, right? The entire rock volume will increase. Sometimes the increased volume becomes about twice the original volume. Thus, the increase in the volume of rocks due to increase in the volume of minerals causes stresses and strain in the minerals of the rock, which ultimately lead to physical disintegration of the rock. Right. So its volume expands. It is like expansion of the clays. You might have seen this. Okay, you might have seen this. Put clay water into clay, it clay swells. Okay, clay swells. As the swelling of the clay goes on, okay, the clay swelling of the clays is going on, what will occur? The it will swell so that, okay, it will swell so that it will become twice its original volume, and some after some time it will be broken mechanically. Okay, it will be broken mechanically. So in a way, the chemical weathering, okay, chemical weathering is leading to physical weathering. Okay, chemical weathering is leading to physical weathering through hydration. Okay, chemical weathering is leading to physical weathering through hydration, right? So hydration is an exothermic reaction and involves considerable volume change, which may be important in physical weathering, exfoliation, and granular disintegration. All these processes, see. So even if we are looking at, or we are studying these processes in isolation, these processes are not isolated from each other, right? These processes are not isolated from each other. Weathering or any landform or any feature is a collective result of all these processes altogether, right? So what is happening here is that whenever these processes are occurring, right? Whenever these processes are occurring, these processes will come or will occur in unison, and these processes will not occur like they are isolated from each other, right? These processes are not isolated from each other; they are occurring at the same place at the same time. Okay. Now, next is hydrolysis. Okay, next is the hydrolysis. Now, hydrolysis is a chemical reaction between mineral and water. That is between hydrogen ions and hydroxyl ions and the ions of minerals. Okay. In fact, the hydrolysis is that process wherein both the minerals of the rocks and water molecules decompose and react in such a way that a new mineral compounds are formed. Okay. They form a new mineral compound. Okay. They form a new mineral compound or new type of mineral is there. Right. The silicate minerals are most affected by hydrolysis. This reaction starts immediately when a mineral comes in contact with water. Okay. As water is coming in contact with the mineral, it will go for hydrolysis and will change the mineral forever. Okay. It will change the mineral forever. Right. So example for this is kaolinization. Okay. Example for this is the kaolinization, conversion of feldspar into kaolinite. That is in the clay. Okay. The next one is the last one is chelation or chelation, whatever you want to call it. It is a complex organic process by which metallic cations are incorporated into hydrocarbon molecules. Okay. In fact, the word chelate means coordination compound in which a central metallic ion is attached to an organic molecule at two or more positions. Okay. One molecule is there, one ionic molecule is there. Okay. One metal is there, and it is attracting the uh, organic molecules. Okay. It is attracting the organic molecules or the hydrocarbon molecules. Right. So this kind of weathering, okay, it will attract the molecules from there, okay, and it will remove these molecules from the original system. Okay, it will remove the particles from the original system, and it will form or it will go for weathering, right? Now, the products of weathering or chemical weathering, solutes of sodium, potassium, calcium, magnesium, etc., produced by the process of carbonation or solution of carbonate rocks, which are brought to the lakes and seas, are reprecipitated to form limestone, dolomites, and other carbonate rocks. Taking from this can be called as Tera Tujhko Arpan, right? Tera Tujhko Arpan, right? Taking from the earth, depositing into the earth, right? Taking from the rocks, taking from the carbonate rocks, and depositing into any water body, right? Forming the rock themselves once again. Okay, so this is a cycle. Okay, this is basically a cycle. Okay, then clays derived from the weathering of feldspar and ferromagnesium minerals form argillaceous sedimentary rocks like shell, right? And then mineral residuals such as silica, unweathered feldspar and mica, and other heavy minerals form clastic sedimentary rocks such as sandstone. So these are the products of weathering under different categories. Okay, got this. So these are the two basic or two important types of weathering. The last one, that is the biotic weathering or the biological weathering, and this is very actually a small topic. Okay, so let us cover this so that this weathering portion is over. Okay, so faunal weathering. Three types of weatherings are there. Okay, three types of biotic weatherings are there: faunal weathering, floral weathering, and anthropogenic weathering. Okay, now faunal weathering means due to the animals, okay, due to these animals, okay, so burrowing animals, worms, and other organisms help in gradual breakdown of the rock or fragments thereof. What actually occur? Burrowing animals or grazing of the animals, okay, grazing of the animals removes the this vegetal cover of on the rocks or the soil considerably. Okay, just like if you have seen these cattle grazing, okay, see these cattle grazing, what happens? Cattle go on grazing on the field, right? Cattle go on grazing on the field, and they eat, or they are grazing as much as they can, right? So if more and more cattle are sent to grazing, they will create, or they will remove the vegetal cover, okay, they will remove the vegetal cover as fast as they can, right? As well as the burrowing animals, right? The burrowing animals, like whichever animals they create their burrows, like earthworms, like hare, okay, like these rabbits, okay, so they will create their burrows, and essentially they will disintegrate the soil, disintegrate the rock. So they actually, there is symbiotic relationship between these animals and the rocks, okay. Rocks provide them the shelter, and these animals provide fresh oxygen fresh oxygen to the soil, right? So this is a symbiotic relationship. But since they are removing of the vegetal cover, okay, they are going for this weathering process, okay, right? So this is faunal weathering, okay, this is the faunal weathering. Another one is the floral weathering. Floral weathering means due to this due to the plants, okay, due to the plants, weathering of rocks by vegetation takes place in two ways. Physical weathering, I have told you physical weathering, how physical weathering goes, right? Penetration of the roots, right? The penetration of the roots. And chemical weathering, which is called as biochemical weathering. So this is something different, okay. Larger plants affect and control weathering in number of ways. So cracks are widened as the roots are deepened. Okay, as the roots are deepened, what will happen? It will widen the crack. Okay, it will widen the crack and widen the and it will eventually break the. Okay, dense vegetation cover generates distinct microclimates at the ground level. Okay, if the dense is there, denser vegetation is there, so microclimatic conditions will be formed, and these microclimatic conditions will lead to formation of a different kind of weathering process, right? So these are the floral weathering. And then anthropogenic weathering, okay. Anthropogenic weathering is nothing but weathering done by human activities, okay. We, the economic and technological man, okay, what we have done, we have cut off the plants, we have chopped the forests, we have created large building, we have created cement roads, we have created tar roads, okay, which we call development, okay. All this we call as development. And during this so called development, we have considerably reduced environmental conditions, okay, degraded the earth. We have considerably degraded the earth, right? And nowadays, apart from any natural agency, human is the dominant agency for weathering, okay. Human is the dominant agency for weathering, because we have created such large machines, okay, we have created such a large machines to break down the rock very easily, okay, break down the rock very easily. Earth will take, or the natural agencies will take, to break a rock or to disintegrate a rock, like hundreds of years, and we can break or disintegrate a rock within minutes, okay. So that is the difference, and human is now become a dominant weathering agency, right? For our industrial purposes, for mining purposes, we need the earth materials, and that has been in having those, okay, in having those materials, we have disintegrated the materials disintegrated the earth, and it has led to weathering and erosion process, right? So this is the anthropogenic weathering. Okay, so this is all about the weathering process. Okay, this is all about the weathering process. You add transportation to this. Okay, add transportation to this, and it will be the erosional process. Okay, this will be the erosional processes, right? Understood? Okay, so we'll stop here. So this is about today's class. In the evening, we'll meet once again at 7. Okay.